Okay, so we've been working a lot with graphing rational functions, and we've learned about vertical asymptotes and horizontal asymptotes and finding x and y intercepts and looking at the behavior. So here is a tool that we can use to put all of this together to graph rational equations, and this is called RATE. And the first thing that you will do on this is that you will determine the roots, the x-intercept, right, the x-intercept root. Then we're going to factor it, and we're going to find any holes or vertical asymptotes. That's the A. T, we're going to determine the behavior at the vertical asymptotes, whether they're together or apart. And E, we're going to determine the horizontal asymptotes. And then the last thing we're going to do is determine the y-intercepts. So this is graphing rational equations using the RATE method. And it's just a way of organizing. It's a tool to organize. Okay, this works best if you just try it. All right, so the R, here's the first example. What I'm going to do is I'm going to determine the x-intercept. And remember that the x-intercept is you're going to take the x, the numerator, and set it equal to 0. So I'm going to have an x-intercept at 0, 0. And so I'm going to go ahead and mark that on here. The other thing I want you to remember, though, is that when the x-intercept is at 0, 0, the y-intercept will also be 0, 0. So that's y-intercept, that's the y part down here. And so there's really no reason to plug a 0 in because it's going to be 0. So the y-intercept is also going to be 0, 0. Okay, so the A are the vertical asymptotes, right? So I look back up here and I see that nothing will cancel in the numerator and the denominator. Nothing will cancel. I would need an x plus 3 to cancel with an x plus 3. The x's will not cancel, can't do that. Okay, so I notice that no, none will, so I have this in the bottom. This determines my vertical asymptote. So I have x plus 3, I set that equal to 0, and I have a vertical asymptote at x equals negative 3. All right, so I'm going to go ahead and draw that in. Here's x equals negative 3. Here's my vertical asymptote. Put little arrows on it. X equals negative 3. All right. So the behavior at this is determined by whether this is a perfect square. So this is not a perfect square. So if it's not a perfect square, then that means that they go opposite directions here. So that's what I'm going to write down here, is just opposite directions. I don't know which direction yet, but I will. All right. Then the E is the end behavior. E is in behavior. And so this is determining a horizontal asymptote. So I go back to my unfactored or even factored, and I look for the highest degree in the numerator, which is an x, and I look for the highest degree in the denominator, which is also an x. So I know that the horizontal asymptote will be at y equals, not 0, y will equal 1, right? Okay, so y equals 1. All right, so I find y equals 1, and I draw in my asymptote. Okay, so this is y equals 1, and I write that in. Okay, well, one thing I notice is that my x-intercept and y-intercept is here in I guess what you could call maybe the fourth quadrant right here. So that's where I'm going to begin. I'm going to follow. I just have the one vertical asymptote, so I'm going to follow it just like that. And I know in a rational function that the behavior at the asymptote was opposite, just like this, opposite. So if this one goes down, then this one has to go up, and that's my graph. Okay, let's do another one. Okay, so I have y equals 5 over x plus 2 quantity squared. So I look at the x-intercept. I let the numerator, that's the first, the r, and I let the numerator be equal to 0, which it isn't. So there is no x-intercept, none. It does not cross the x-axis, which probably is going to mean that I have an asymptote there, but we'll see. So vertical asymptote is the denominator, right? So I have x minus 2 is equal to 0. So x equals 2 is my vertical asymptote. And then because this is a perfect square, that means that the behavior at the vertical asymptote are together. Now they could be up, up, or down, down, either one, and I don't know for sure yet, but that's part of it. So I'm going to draw in my vertical asymptote. I'm going to write x equals 2, and I'm going to put that they are together. Okay, they are together. Okay, so then the horizontal asymptote, the end behavior of the horizontal asymptote, I look and I have x to the 0 in the numerator, and in the denominator I have x squared, so it's bottom heavy. It's bigger on the bottom. If it's bigger on the bottom, then my asymptote will be on the x-axis, which is y equals 0. Y equals 0. Okay, and then the y-intercept, the y part, the y-intercept is where I let x be 0. So I have y equals, I have 5 on the numerator, and then I have 0 minus 2 squared, so y equals 5/4. So at 0, 5/4 is going to be, bink, bink, right there, is going to be my y-intercept. And that's my clue as to what graph I'm doing. So I'm going to go ahead and follow the asymptote, go through the y-intercept, and follow the asymptote. All right? And then this time I know that I have the same behavior. So if it goes up on this side of the vertical, it's got to go up on this side of the vertical. So once again, I don't cross the horizontal here, and I go up, and that's what it looks like. So it blows up together. Okay, on this last one, I want you to graph this one in your composition notebook. Most of you are watching this before class, so I want you to write this problem down in your composition notebook, and I want you to go through the steps just like we did on the last 2 problems on the video. And then we'll be doing a bunch more of these in class until we get the hang of all 5 parts. All right? So I'll see you then. Get to work.